Welcome back. Today's section is section 8.1.1 confidence intervals. So please, I highly request you all to pay complete attention, have your pen and paper ready so that you can take notes. I will be posting this PDF under the video so you have a copy of this one. So the first thing we're going to talk about is point estimate. Now, if I ask you, what is the height of human race? You're going to give me one value, right? You're going to say probably average is 5.5 foot or 5.6 or whatever is the average. That's what you're going to tell me. Now that's the one value that you give me is called a point estimate. So let's go ahead and read what point estimate means. It's a number calculated. So you take a sample, you calculate whatever you're calculating, and that the value that you get is called the point estimate. And keep in mind, why do you take a sample? Because you always want to infer about the population. So point estimate is the value that you get from taking a random sample to approximate the population parameter. Now, confidence interval. Now, if I ask you the same question again, I say, what is the average height of human race? And you give me a value. Write down that value on a piece of paper. Now I'm going to ask you, how confident are you? Right? When I say how confident, you'll be like, I don't know. But if I ask you to give me a range, let's say from 5 foot to 6 foot, definitely that average population height has to be between 5 foot and 6 foot. So as soon as you move from point estimate to a range, look what happens. Your confidence increases, and that's exactly what confidence interval is. And why does that increase? Because you know that the population, the average height of human race has to be in between 5 and 6. Now, how confident are you? That's the next question. But you see, confidence interval is something that you're telling me that from this range to this range, I'm confident that the population parameter has to be in between these two values. Let's go ahead and read it. The range of values calculated from the set of data that can be used to give the probability that that interval contains the true value of the population. That is called your confidence interval. So you're telling me that I am 90% sure that the real population value or parameter is in this range. Now the next one is margin of errors. Definitely when you're estimating something, there has to be room for error because we are humans. We cannot be 100% correct. So that margin of error is a measure of width of confidence interval. The margin of error can also be referred as error bound. Now that might not make any sense to you, but the margin of error, the error is the value that you got, the difference between the value that you got and the exact or the approximate, not the approximate, but the exact value of the population. It's the difference between the real value and the value that you got is the margin of error. Okay? All right. Let's go ahead and take a look. Oops. Let's go ahead and take a look at formula to calculate the confidence interval. All right, before I go ahead and do that, um, let me think of an example. And I'm going to give you an example of what a point estimate is, what a margin of error is, what a confidence interval is. So let me go ahead and pick my handy dandy pen here and let me try to draw a line. So this is my, okay, let me click this again. All right, so this, I have a perfect straight line now. So if let's just say this is the real mean of the population, which is mu. And so let's just take an example. Let's just say this is the real mean of human race. Let's just take an example here. Let's just say this is the real mean of some population. Let's say you're trying to calculate the height of human race, and this is actually the height of human race. I don't know what the value is because I cannot be 100% sure. Now, if I ask you, you will give me a range of numbers. So let's just say your range is from 5 feet to 6 feet. Do you see that? So this range of 5 to 6 is your confidence interval. This is your upper limit. The 6 feet is your upper limit and your 5 feet is your lower limit. All right. Now, let's just say that the actual human average height of a human race is 5, again the wrong pen, is 5.5 foot. Let's just say, okay? Don't quote me on this one. I'm just giving you an example because I don't want you to emailing me and saying, Miss, this is what I found. Let's just say this is what the average height of human race is. So this is the actual average height of human race, and this is what you estimated, 5 foot. This is the confidence interval that you gave me. This is the range that you gave me. You gave me a range from 5 foot to 6 foot. Now the difference between what you gave me and what actually is called the error, margin of error. Make sense? So the difference between what you gave me and what actually is called margin of error. So this is your margin of error. Fair enough? And your confidence interval is simply your actual estimated mean plus the margin of error, and estimated mean minus the margin of error, plus and minus, because it's 5.5. So what's the error? The error is 0.5. 5.5 minus 0.5 gives you the lower limit of your confidence interval. 5.5 plus 0.5 gives you the upper limit of your confidence interval. Fair enough? All right. Now that we know what a point estimate is, what a margin of error is, and what confidence intervals are, let's go ahead and dive right into the problems. Certain things that you have to know: population mean, the mean of the entire group being researched, and it's represented, population mean is represented by mu. Sample mean is x bar. Sample mean is nothing but you take a sample, find the mean, that's x bar. And usually you are using your sample mean to approximate your population mean, which is usually unknown. Now let's go ahead and look at what population proportion is. But before I go ahead with population proportion, I want to talk about sample proportion. Let's just say I want to find out what percentage of people in US vote for Republicans. I know I can't ask everyone. As you can see, Facebook, Twitter, they're all doing their own research. I'm going to ask 100 people, and if I get 54 percentage from that sample, so that 54 percentage could be Republicans or Democrats. Let's just say 54 percentage is Democrats, right? So I'm going to say from my sample proportion, that 54 percentage that I got from the sample is my sample proportion. And using that sample proportion, I can infer something about my population proportion, all right? Empirical value, very, 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 very important. And what is that? So in a bell-shaped curve, if I have a bell-shaped curve, and this is my mean, 68% of my data values are within one standard deviation. 95% of my data values are between 95% of my data values are between two standard deviations, and 99.7%, so values are between three standard deviations. Very, very, very important. We're going to be talking more about this as we get into confidence intervals, but please make sure you know these values. If you don't, make sure you write them down. So majority of the data lies between one standard deviation. When I say majority, 68%. 95% of the data falls between two standard deviations. 99.7% of the data falls between three standard deviations. Now the next most important one, confidence interval. Confidence interval is the region formed between the point estimate minus the margin of error, point estimate plus the margin of error. Like we've seen these two. Let me go back to that. So this is my confidence interval. So point estimate plus margin of error, point estimate minus margin of error. So you might ask, Miss, when do you do that? Remember, you cannot find the population mean. There's no way you can find the exact value of population. That's why you use sample to infer about population. Because giving a point estimate is not accurate. You always make sure you give a confidence interval. You give a range of values. You say, probably the height of human race is from 5 foot to 6 foot. When you give me a range, that means there's more scope of me that it could be anywhere in that value instead of giving me one exact value. All right, the next one is confidence level. So level is, when I say confidence level, automatically I'm talking about how confident are you? You're going to say 60%, 70%, right? When I ask you how confident, that is my confidence level. As soon as you give me percentage, that's probability. As soon as you know it's probability, it's area under the curve. Now we see how everything is connected? Let's go ahead and take a look at the problem. All right, all right. Which one is it? Okay. A company sells juice in 1 quart bottles. In a quality control test, the company found, let me move this. The company found the mean volume of juice in a random sample of bottles was 27 ounces. So the mean was 27 with a margin of error of 4 ounces. Now, let's forget about statistics. You are in the company and they say the error is 0.4, the error is 4 ounces. What do you think? That means from 27 ounces, it could be zero point 0.4 more or zero point 0.4 less, right? It's as simple as that. That's my confidence interval. I'm telling you, I can only make an error of 4 ounces. That means I can go up 4 or down 4. Let's go ahead and do this problem. All right, so the point estimate or the sample mean is 27 ounces. And the margin of error is 4 ounces. And you're asking me to construct the confidence interval. Remember what confidence interval is? Point estimate plus margin of error. Let me move to that formula. Calculating confidence interval is point estimate minus margin of error, point estimate plus margin of error. So once I know that, let me go back here. So this is So it's point estimate minus margin of error. That is my lower limit. Point estimate plus margin of error. I'm going to put ME for margin of error. So it is 27 minus 4, comma 27 plus 4. I don't want to write on my face, but 27 minus 4 is 23. And 27 plus 4 is 31. So your confidence interval is 23 and 31. So you're telling me that, I am whatever percentage you're confident, I know that the average mean of this bottle is going to be in between 23 and 31. Because what's the error that you can make? Only 4 ounces, right? So any bottle that you pick, the average weight is going to be between 23 and 31. Let's take a look at the next one. Oops. Amy, a nature photographer, randomly sampled photographs she took within last year. She wanted to find out how many of her photographs contained flowers. The proportion of photographs that had flowers was 0.61, with a margin of error of 0.04. Again, it's like give or take. So consider margin of error as give or take, right? So I know that the confidence interval formula is point estimate minus margin of error. Confidence interval means lower limit, upper limit. And point estimate plus margin of error, right? What is my point estimate? 0.61, margin of error 0.04. Now my confidence interval is 0.61 minus 0.04, 0.61 plus 0.04. And what is that going to be? This is going to be 0.65, right? And this is, I should have moved it up. Let me go ahead and rewrite this one. So this is going to be 0.61 minus 0.04. and 0.61 plus 0.04. So this is 0.65, right? This is 0.61, 60, 57. Fair enough? All right. Now let me take a look at the time. Okay. Calculate a margin of error given a confidence interval. So it's the basic formula. They're giving you the confidence interval, upper limit, lower limit. They're asking you to calculate the margin of error. So what they're doing is they're giving you 5 foot and 6 foot, and they're asking you to calculate the margin of error. So what's the distance between 5 foot and 6 foot? 1 foot, right? But the margin of error is half of that because your mean is in between. Do you see that? So it's 0.5. There's a formula for that. We'll simply go ahead and calculate its upper value of your confidence interval minus lower value divided by 2. As simple as that. So Michelle, a student studying music, randomly sampled fellow music majors and asked whether they'll listen to music while they study. I just can't listen to music. I have to have complete silence. The resulting confidence interval for the proportion of music students who listen to music while studying is. So look at this. So they're 0.09 to 26 is a huge range. And that is my confidence interval. What is the margin of error? So this is where I am. So this is 0.09 all the way to 0.26. So my margin of error is the whole distance divided by 2 because in somewhere in between is my population mean. So the upper limit, but I'm going to use the formula. The upper limit is 0.26. The lower limit is 0.09. Fair enough? Now when I plug into the formula, I don't know why I did not leave myself enough space. When I plug into the formula, which is right here, upper limit is 0.26 minus 0.09 divided by 2. I'm going to go ahead and show you all how to plug this into class calc as well. Open parentheses, 0.26 minus 0.09, close parentheses, divided by 2. So my margin of error is 0.085. So my margin of error is simply, let me move this here, 0.085. All right, let's go ahead and take a look at the next one. Suppose we know that a confidence interval for population proportion is, again, they gave me a confidence interval. That means they're telling me the lower limit and the upper limit from here to here. With the sample proportion of 0.167, what is the margin of error? So there are two formulas, but I simply like to follow one formula. And that's what I expect you all to do too, so you're not confused. So what they're saying is 0.572 is my lower limit. This is where the lower limit is. Oh, that's a straight line. And my upper limit is 0.662. And they're saying my population, the sample proportion is in between, which is 0.617. And they're asking me to calculate the margin of error. There's so many ways you can do that. You can simply subtract this from this and you get your answer. Or you can subtract this from this and you get your answer. But I like to keep it constant. So I'm going to go ahead and write my upper limit, 0.662. Lower limit, 0.572. The margin of error, ME, is, I'm going to use the formula which is right above, which is upper limit, 0.662 minus lower limit, 0.572, whole thing divided by 2. Okay, let's go ahead and plug this into class calc. I'm showing you all using ClassCalc because I want you all to practice using ClassCalc as well. When you all do it on the test, you're not too overwhelmed. So 0.662 minus 0.572 close parentheses divided by 2. So here my margin of error is simply, I'm going to use a different pen, is simply 0.045, and that is my final answer. Okay? All right, now let's take a look at the next objective, that is calculating a point estimate given a confidence interval. Again, it's the same formula. Make sure you please write these formulas down. Where is my mouse? Make sure you please write these formulas down. So going back to what we did before, they're asking us for point estimate. Keep in mind, point estimate is nothing but your sample mean. So let's go back to the same example that we did. If, let me see if I have place here. So if the estimate is of human height is 5 feet, that is the lower limit, and the upper limit is 6 feet, and this is my lower limit, upper limit. They're asking you to find the sample mean, which is exactly in between. How would you do that? Simply upper limit plus lower limit divided by 2, right? So please make sure you write down your formula. So point estimate is upper limit plus lower limit of your confidence interval divided by 2. Let's go ahead and take a look at the first problem. The height of American men, hey, they copied us. The height of American men are normally distributed if a random sample of American men is taken and the confidence interval is 66.2 and 74.6. I'm guessing this is in inches. What is the sample mean? Or what is the point estimate? So my upper limit, so here I'm going to say my upper limit is 74.6. My lower limit is 66.2. According to the formula, it is upper limit, which is 74.6, plus the lower limit, plus 66.2 divided by 2. And again, I'm simply going to go ahead, plug this into my handy dandy ClassCalc. I forgot the numbers already. 74 points, no, never mind, parentheses first, 74.6 plus 66.2, close parentheses, divided by 2. Boom, there you go, 70.4. So my sample mean here is 70.4, which is exactly in between. 70.4, and that is my final answer. Let me highlight it just because I can. All right, now let's go ahead and take a look at the next one. What do I have? Suppose that we know, let me expand this. Suppose that we know the confidence interval is, again, they gave us a confidence interval of, I have a lower limit, I have the upper limit. What is the margin of, with the margin of error of 5, find the sample mean. Now there are two ways to do it. So this is what they're telling me. My sample mean is somewhere in between, right? And this is my lower limit. This is my upper limit. That's not in between. Yeah, that's good. This is my upper limit. And my margin of error, that is this distance, is 5. And this distance is 5. That's my margin of error. So they're asking me, how can I find this one? Simply, I can say it is 46 plus 5, or it is 56 minus 5. As simple as that. In the previous case, I do not have my margin of error. My margin of error is missing in this case. When my margin of error is missing, I use the formula lower limit plus upper limit divided by 2. Now, if you don't want to confuse yourself with two different formulas, you can just stick to one. Let's go ahead and do it that way. I'm simply going to go ahead and add. So, boom. My upper limit is 56. My lower limit is 46. And I'm trying to find the margin of error using one formula. No, not my margin of error. I'm trying to find my point estimate or the sample mean, point estimate or my sample mean using one single formula. It is my upper limit plus lower limit divided by 2. So what do I have? I have 102 divided by 2, which is 51, right? Or even if you add these two, let me change the color again. If you add 46 plus 5, you still get 51. Do you see that? Upper limit, margin of error gets you to the middle. Or if you subtract 56 minus 5, you will still get 51. So either way, whichever way you're comfortable with. All right. Now let's go ahead and take a look at something that is very important and I've been waiting for, which is section 8.2. I don't have a worksheet for that because I have to show you the stimulation. So let's go ahead and jump right into it.